video I'm going to discuss 5 physics problems of AAI ATC 2021 Shift 1 paper. So I hope you will enjoy this video. If you enjoyed, please like, share and subscribe, and if you have anything in mind you can comment in the comment section. Thank you. Let's solve the problems. Let's look at the next 5 problems. So as you can see, the 21st problem says an object of mass 5 kg is sliding with a constant velocity 12 meter per second on a frictionless horizontal table. The force required to keep the object moving with the same velocity. Since there is no friction, so the only force that is acting on the body is to provide the constant velocity 12 meter per second. So as we know from the Newton's second law, force is m times rate of change of velocity. So here v is constant, so dv dt is 0. So net force required to slide the object with a constant velocity 12 meter per second is 0 Newton. Option C. Now the 22nd problem says a body cools from 70 degrees Celsius to 40 degrees Celsius in 5 minutes. Calculate the time it takes to cool from 50 degree to 20 degrees Celsius given the surrounding temperature is 10 degrees Celsius. So we need to know Newton's law of cooling for this problem. So according to Newton's law of cooling, T initial minus T final divided by the time of cooling T is K. K is a property of the body. It depends on the thermal conductivity, the conductivity rate and area and so on. We multiplied by Ti plus Tf by 2 minus T surrounding. So from the given information 70 degree to 40 degree cooling in 5 minutes, we need to find out this K, and then we need to put the value of K for the case of Ti is 50 degrees centigrade and Tf is 20 degrees centigrade. So let's calculate. To evaluate K, we used to first use this information. So if we put that is Ti minus Tf is 30 degree, 30 by 5 minutes is K into Ti plus Tf is 110, 110 by 2 is 55, 55 minus 10 is 45. K into 45, that implies K is 2 by 15. So now we have to put this value of K here. For Ti is 50 and Tf is 20. Again, the left hand side would be 30 by T into 2 by 15. Ti plus Tf by 2 in this case is 50 plus 20, 70 by 30 by 2 is 35, minus 10 is 25. So if you do the calculation, you will get each 9 minutes. Option C is correct. Now 23rd problem says if find the focal length of convex lens of focal length 50 centimeters which is in contact with a concave lens which has a focal length of 40 centimeter. So we need to find out the resultant focal length of the lens system. So as we know, the resultant focal length of a lens system, which is a distance d apart, follows the formula. The resultant lens system has a focal length f. This is the focal length of first lens. This is the focal length of second lens, f2. Then d by f1 and f2. This is the separation between the lenses. So we need to find this f, given f1 is 50 because for convex lens the focal length is positive and for concave lens the focal length is negative 1 by 40. So as you can see, this 1 by 40 is greater than 1 by 50. So the system will be diverging system, and if you calculate this, it would be minus 200 centimeters. That means it is a diverging system. Option A is correct. Now at 24th problem says, at what depth from the surface of water the pressure will be equal to 3 times the atmospheric pressure. So as we know from the Bernoulli equation, change in pressure is basically rho times the acceleration due to gravity times the depth. So we need to find out the depth. This is delta P by rho G. So delta P is 2 times P atmospheric divided by rho G, but you need to be careful here because that is centimeter square. So 2 into 10 divided by 10 to the power of minus 4 into rho is 100 in SI units, sorry 1000 in SI units, and G is 9.8. So basically that is 200 by 9.8, and the answer is 20.4 meter. Now 25th problem says which of the following statements is incorrect for heat. So this is an informative question, and correct answer here is option C, that the temperature of the two bodies are same even if their heat contents are different. This is not true, because we know from the 0th law of thermodynamics, if two bodies are in contact, they exchange heat between them until they become they come to a equilibrium state in which the temperature of both the bodies become same. So option C is the incorrect statement. So these are the 5 problems of ATC 2021 paper. Thank you.